Hey there, this is Tony Verbsky here. Just doing section 4C. Some of you will like the initial start because it's formula based, and some of you will not like it because it's formula based. We got ourselves a big old formula for savings plan. It's a savings plan formula with regular payments, and it's pretty big. So I'll get on it and write it in terms of the book, and then I'll write it in terms of the way I'm used to seeing it. But final amount is your payment. So, like you make monthly payments into a savings account, and there's this big, huge formula, very similar. This is the APR, annual percentage rate, divided by the number of compounding periods, N, that's the book. Let me get some parentheses on here, to the NY, where Y stands for years and N is compounding periods. Then they go minus 1, and to make matters worse, they go over the APR divided by N. Now that's the books. I do like the PMT, standing for payment. I like 1 plus R over M, where M is my compounding periods, to the MT, where T is time in years, minus 1 over R over M. I think mine's better. Okay, so let's just get right on it. We're going to plug in a bunch of stuff, and then we're going to get an answer. It's a really cool formula, actually. So here we go. So let's make payments of $100 per month, which implies M is 12 because the word month was used. And we'd like to know our final amount after 5 years, when the rate is 4%. So answer is 100. 1 plus the decimal version of the percentage divided by 12 to the 12 times 5 minus 1 all over 0.04 divided by 12. Now let's do 0.04 divided by 12. Let's get that. With these fancy calculators, you can type it all in, but 003 repeating. So we get 100, 1.003 repeating. I know this is 60 minus 1 over 0.003 repeating. Now I got to do this next, and sorry to run into that last calculation, but I got to raise that to the 60th. And let me see if I can finally change this view. I changed it the other day. Options. Always show Wabbit on top of other windows. Oh, apply. Oh, okay, there we go. All right. Oh, still calculator. Options. Okay. I don't know why it keeps going away. Okay, anyway. Um, plus 1. So raised to the 60th. Okay, so here's where people are making a mistake. Actually, so I got that to the 60th, I'm going to write it down. This is going to kill me if I don't get this fixed. Maybe now. Nope. I'm going to keep it over here. And then does it go away? Well, that sure does. All right. So 1, 2, 2. This might drive you crazy. It's going to drive me super crazy. 0996 594. So you need to carry all the decimals. Oopsie, -1. Divided by 0.003 repeating. So then I'm going to subtract 1 and multiply by 100. So subtract 1 times 100. Then I get 22 point, view, detached LCD, view, detached LCD, and okay, well, calculator, options, load files, screen capture, automatically save, apply, always show on top, apply, okay, sorry, killing me. 09965, 09965, 939 divided by 0.003 repeating. So on my calculator, divided by 0.003 repeating, and I get $6,629. Look at the third decimal, 89 cents. Nope, 7.90. So bottom line, you put in 160 times for $6,000. Therefore, the interest was $629.90. So don't know what they're asking, but that is a good way to go. What I don't like it when they say for 6 months. When they say for 6 months versus my 5 years, you got to let time equal 1/2. There's a example in the book, and that's the first one they do. Kind of a dumb problem, if I don't say so myself. So this is a one, and by the way, this example, I bought savings bonds. They're double E savings bonds online, and I set it to $100 a month for 5 years. And this is almost the exact situation where I just for 5 years bought savings bonds at $100 a month, and they did yield about 4%. And that's almost the exact amount of money I have in there, except I just kept them in there for, I don't know, 15 years now. So it's probably $7,928.52, something weird like that. Anyway, here we go. Next example. Now, this is the college savings example. Your goal is to build $100,000 for a final amount. And then you got your payment, and you got this. I'm getting good at it. Just as I say that, 1 plus R over M to the MT minus 1 all over over M. So you're going to try to solve for payment. So we'd be better off actually creating a payment formula instead of you know doing the math. So I'm going to give you a second formula. All I'm going to do is put this up there and that down there. So if they want to know the payments you need to make, this number here is your final amount. Then you just multiply it by R over M, but you divide it by minus 1. So here's a second formula if you want to call it a second formula. But here's the problem. Now I want $100,000 for a final amount. And this is for college savings. And this is directly out of the book. I better read it. Over 18 years, monthly payments. So monthly payments means M is 12. So, and we're going to have a rate of 3%. Now, 3% is kind of pathetic, but very conservative. So, 3% compounded monthly, 1 plus R divided by 12 to the 12 times 18, because it was 18 years, minus 1. Now, this time, I'm going to do a little more math since my calculator's flipping back and forth, and I don't know why. I'm going to do the bottom and the top. So I'm going to just do the top all at once. So 100,000 times 0.03 divided by 12. Whoa, 250. No way. Over 1 plus 0.03 divided by 12, enter. Raise it to the 12 times 18. I don't really know what 12 times 18 is. 180 and 12 and 12, 204. Minus 1, 0.714, 850. 0.714, 850. 874. Now I'm going to do this for real. You could actually divide it backwards. So if you can go divided by 250, and this x to the minus 1 key is the flip it over key. That's usually what I do. But for those of you who are not into that, 250 divided by 0.714, 850, 874, 250, second, insert a divide sign. Love the TI-80 384 family. And I get 349 point, look at the third decimal, 72. So if you want $100,000, you need to be putting away 349.72 over 18 years. I don't need to be talking about my daughter, but I will. She's getting her doctorate in physical therapy. The degree costs $260,000 almost everywhere. She got her 100,000 off. Good kid, all that. Swims. So basically, we got it down to about $160,000. She's going to have about $60,000 in loans, and there you go. The Verbskis need $100,000. And what have we been doing? We've been putting away $500 a month for about 13 years. So, bottom line, a little short, covered some out of pocket, but looks like the family might get it done. Still unsure. So she's on year 4. So maybe the money will last, maybe it won't, but we'll figure it out some way, somehow. Um, everybody takes a team to pay for college. Okay, so love the 2 problems. Here's another really cool example. Um, I'd like to retire 25 years from now. So let's not look at it like this. You would like to retire in 40 years. Here, let me pause this. So pause. Tony Verbsky here. Sorry, thought it was one of you guys. I was just keeping my phone on when I'm at home. When does the scholarship? Okay. All right, here we go. Sorry, I got all sorts of people texting me, mostly students right now. Here we go. So you like to retire in 40 years, and you like to have $100,000 per year. So how can we do this? Um, so there's a couple ways you can do it actually. Um, it says I'm just reading out of the book here, see how creative they got. So what you need to earn 50,000 annually from interest. Since we are assuming that the APR is 7%, ooh, 7%, ooh, yeah, that's about right. Then this is their problem. 50,000 um, 7% equals the total balance. So $100,000 must equal 0.07 times the balance because you need interest. 100,000 in interest each year, and basically there's gonna be a ton of money left over with this plan. This is crazy. Um, so this will go on forever times the total balance. I'm not sure I like this problem. Basically, you would get the money for 40 years, and then your kids would continue to get 100,000 till they die. This is not realistic. I'm canceling the problem. Um, it would be a much better problem. Oh, let's not get crazy here. So I'm going to move on. Actually, you know what I'm going to do? Um, hate to stop the lecture in the middle of this small train wreck, but if we keep this section, where I just make multiple 4C assignments, I think we're going to be better off. Because right now, we only got the initial problem where you just plug into this formula. And then we got the second problem, which you plug into this formula. And that's all we really got. And I'm into it for 19 minutes. I'm going to call it a day here and then turn around and make a 4C part 1 assignment. And instead of like, some of you don't like it when the lectures are really long and you don't like the big assignments. I'll keep the assignment down to a minimal. So hopefully we go with like a 4 to 5 question assignment, and then we'll finish section 4C. So yeah, I think you'll like it better. There's a lot of lingo in the remaining section, and it's kind of separate. So that's what we're doing. So end of this lecture, I'll do a second part on Friday. Give me a call if you need any help. 720-985-1986. If you haven't figured it out, I'm more of a texting guy. Um, like it, my the email at Metro, seems like sometimes I just forget to check it. I'll try. I think there's only one of you actually emailing me now, at Metro. So give me a text, give me a call. I'm more of a personable guy, and I'll try to address your stuff, over the phone or via text. Anyway, see you later. Bye.